we are going to look at the properties of limits of our function. In other words, these are the laws which we are supposed to follow when we are looking at the limits of a function. So, for example, suppose our function of the limit of a function f of x as a x turned into a is the same as a L1, and the limit of our function g of x for x turning into a is the same as a L2. Now, like this example, now here we are going to look at our example. That was the starting point to make you to understand this knowledge for limits of a function. Suppose the number like the limit when we are adding our function f of x plus our g of x for x turning into a. This one is the same as the limit of our function, f of x plus g of x for x turning into a. But now here we facilitate from up here that for the limit of a function of f of x for x turning into this a. But this a is just a constant. That means that any number is represented by this a. This one is the same as our f of x is the same as L1. Now here you don't say again that the limit of L1 for x turning into a, but instead you just put L1 plus our L2. So this one is our first property. Now we are going to look at the second property. For the limit of the function, our function f of x multiplying it with a function f of g for x turning into a. This one is written as the limit of our function f of x multiplying it with the limit of a function g of x for x turning into a. Here also with the x turning into a. This one is the same as, but our limit of a function f of x for x turning into a is represented by L1. Here my times the limit of a function g of x for x turning into a is the same as L2. So this one is our second law, our second property for multiplication. Now we are looking for the second one again, which says that for our third one is now for the limit of a function f of x divided by g of x for our x turning into a. Remember, this one can be written as the limit of the function f of x for x turning into a divided by the limit of the function g of x for x turning into a. But our f of x, our limit of f of x for x turning into a is the same as L1. And for the limit of a function g of x for x turning into a is the same as L2. So this one is again another property for the limits of the function. Let's look at the next one, which is our first point now. For the limit of the function, any constant of g of x for x turning into a, this one is written as, this a is a constant which you can, okay, let's use a different letter. Suppose we use the m. Now we are going to pull this m out. This one is the same as m limit of the function, our g of x, for x tending into a. But we know that this n is our constant, but the limit of the function for x tending into a is the same as from up here, is the same as L1. L1. So this one is another property. So members, we are going to look at our example. We are going to look at examples to understand these properties more. Our example 1 says, suppose that suppose the f of x is the same as x squared, and the g of x is the same as x squared minus 1. Then find our Roman number 1 says the limit of our function f of x plus g of x for x tending into 2. Now remember, this one is our example. Our solution goes like this. Now here we are going to say that it's the same as our limit of the function f of x for x tending into 2 plus our limit of the function g of x for x tending into 2. Now from here we are going to represent our limit of the function f of x from up here is to say that it is x squared. Now here we shall say x squared plus open bracket is the same, our g of x is the same as 2 squared minus 1. Now there we are going to collect our like term, which is the same as x squared minus 1. This one is the same as 2x squared minus 1. Okay members, let's first repeat it here. This one is the same as our limit of the function. Our limit of the function f of x is the same as x squared plus our limit of the function g of x is the same as x squared minus 1 for x tending into 2. Now here we shall get our limit of the function. We are collecting like terms. When we add this x squared plus this one is the same as 2x squared minus 1 for our x tending into 2. Now this one is the same as, now here from this point we are going to substitute the value of x to be 2 into this equation for the limit of the function. Now this one is the same as 2 times 2, but this 2 is squared minus 1, yes. Now here we shall get 2 times 4 minus 1. This one is the same as 8 minus 1, which is the same as 7. So this one is our answer. Let's look at another example. Our second example says, let's find the limit of the function g of x divided by f of x for our x tending into 1. Now members, here we shall say our limit of the function g of x for x tending into 1 divided by our limit of the function f of x for x tending into 1. Now this one can be written as, now here we are going to replace the value for the limit of the function g of x. Now our g of x is the same as, now here we shall say our limit of the function g of x is the same as x squared minus 1 for x turning into 1 divided by the limit of our function x squared for x turning into 1. Now this one is the same as, now here we are going to substitute this 1 into that whatever. Now here we shall get 1 squared minus 1 divided by 1 squared. Now this one is the same as 1 squared is the same as 1 minus 1, the same as 0 over 1. Now this one is the same as 0 divided by 1 is the same as 0. So that one is an application of another property again. We are going to look at another one again. Now we are going to our third example, that suppose that you find the limit of the function, 5 g over x for x tending into 3. This one is the same as our limit of the function. Okay, now here this 5 is a constant. Now we are going to pull this constant out. We shall have 5, the limit of the function g over x for x tending into 3. This one is the same as a 5, but our g over x from up there is the same as a x squared minus 1. So we shall have 5, our limit of the function x squared minus 1 for x tending into 3, which is the same as a 5 into 5 into. Now here we are going to substitute the value of x, which is the same as 3 squared minus 1. Remember, this is the same as 5 into 3 squared is the same as 9 minus 1. This is the same as 5. 9 minus 1 is the same as 8. So 5 times 8 is 40. Yes. So members, thank you for listening to me. I remain as it, Mr. Odeke James, taking you through the properties of limits of the function. Let's meet next time. Thank you.